Hi, fourth graders. It's Mrs. Ramsey. Today we're going to be going over 12-4 independent practice for math, and we're going to be going over questions number 21, 26, and 27. So we're going to start with 21 first, and we're adding 44 100ths plus 34 100ths plus 9 tenths. In order for us to be able to add all of these fractions, we first need to find an equivalent fraction for 9 tenths, because all of our denominators have to be the same in order for us to add. So I'm going to change 9 tenths into an equivalent fraction with a denominator of 100. So in order to do that, I know that I need to multiply 10 by 10 to get 100. And whatever I do to the bottom of my fraction, I always need to do to the top, the numerator. I need to multiply my 9 by 10, which gives me 90. So my new equivalent fraction is 90 100ths. So I'm going to actually go up to the problem, and I'm just going to add on my zeros and make this fraction 90 100ths. Now I can add, now I can add all of my numerators, and I can do that in my head, but it's best to write them out. So I'm going to add 44 plus 34, and that equals 78. And then I need to add 90 to 78, and I get 168. So my numerator is 168, and my denominator stays the same, 100. However, 168 over 100 is an improper fraction, so I need to change my improper fraction into a mixed number. In order to do that, I ask myself, how many times can 100 go into 168? And I know that 100 can go into 168 one time, with 68 left over. So I would have 68 100ths left over. So my final answer is 1 and 68 100ths. Okay, we're going to do number 26 together now, and this is a higher order thinking problem. So let's read this one together since they tend to be a little bit more difficult. Of the first 100 elements on the periodic table, 13 100ths were discovered in ancient times, and 20 100ths were discovered in the Middle Ages. Another 5 tenths were discovered in the 1800s. What fraction of the first 100 elements was discovered after the 1800s? Explain. So in this problem, I want to find out what was our total before the 1800s. And I know that ancient times and Middle Ages are before the 1800s. And then I also can see that 5 tenths were discovered in the 1800s. So if I find the total of all three of those, whatever is the missing part will give me my answer after the 1800s. So let's do this together. The first thing I'm going to do is write 13 100ths from the ancient times, and I'm going to add that to 21 100ths from the Middle Ages, and then I'm also going to add 5 tenths that were discovered in the 1800s. In order for me to add these, though, I need to make sure that my denominators are all the same. So I can see that 5 tenths is not, so I need to make tenths into 100ths. So I need to find an equivalent fraction. So I'm going to put 5/10 here. And I want it to make something equal in the hundredths. So in order to do that, I ask myself, how did I get from 10 to 100? And I know that I multiplied by 10. And then when we find equivalent fractions, we always multiply the top, the numerator, by the same thing as the bottom, the denominator. So I'm going to multiply 5 by 10, and that gives me 50. So my equivalent fraction to 5/10 is 50/100ths. So I'm going to change my 5/10 here to 50/100ths. And now I can add each of my fractions because they all have the denominator of 100. I'm going to add 13 plus 21, and I get 34 plus 50 equals 84. So my total is 84/100ths. My total represents everything that happened up to the 1800s. My answer, they want me to find what was discovered after the 1800s. I know that if I add 84/100ths plus 16/100ths, that equals 100/100ths. So my missing part is 16/100ths. And that is your answer for number 26. However, you need to add your units. So 16/100ths of the elements. Okay, let's try and solve number 27 now together. I actually think this one's a little bit more difficult than number 26, but let's read it together. Delilah knocked over 7 out of 10 pins in the first frame of bowling. The next 9 frames she knocked over a total of 67 more pins of the 100 possible pins in the game. Delilah wanted to find the fraction that represented the number of pins she knocked over in the game. Her work is shown below. So in her work, you can see that she wrote first here 7 out of 10 pins for the first frame plus 67 out of 100 possible pins in the game. Then you see that she changed 7/10 to 70/100ths because she wanted to find an equivalent fraction with the same denominator, added them together, and got 137/100ths pins. My question for you is, can you bowl and knock down more pins than you have in the total game? So she said she knocked down 137 pins out of 100. How could that be possible? Well, she made a little mistake. Instead of writing 7 out of 10 pins, she should have written 7 out of 100 total pins plus 67 out of 100 pins. Then added those together, and she would have gotten 74/100ths. I think this problem was a little tricky because the 7 out of 10 pins in the first frame, each frame that you bowl, you have 10 pins in each frame. So 10 pins in 10 frames equals 100. So the 7 out of 10 is just the first frame. The 67 out of 100 was 9 frames. So each frame, the 9 frames she bowled, she knocked down 67 pins out of 100 total. So when we added these fractions, it should have been 7 out of 100 plus 67 out of 100. So Delilah's equation should have been what you see. I can't forget my unit